Imagine walking into a high-stakes interview at one of the world's most innovative fintech companies, Stripe. You've prepared for weeks, mastering every system design resource, and now you're about to face a technical challenge that could change your career. This is the story of how a single whiteboard session became a masterclass in both technical excellence and the importance of empathy in engineering. Let's dive into what really matters when designing systems that handle real money for real people. The interview was set for 45 minutes with a senior staff engineer. After a brief introduction, the challenge was clear and direct. Design a payment retry system at scale. This wasn't just any technical question. It was a test of your ability to think like Stripe. The adrenaline kicks in, and you realize this is your moment to shine. The pressure is on, but so is your preparation. You've spent countless hours preparing for this moment. From diagramming URL shorteners in your sleep to reciting the CAP theorem while brushing your teeth, you're ready for anything. The role is backend-heavy, focused on infrastructure, and every line of code could impact real dollars moving between real bank accounts. The stakes are high, and your technical foundation is solid. Within the first 10 minutes, you map out a clean, high-level architecture on the whiteboard. An API gateway ingests payment requests. A message queue decouples the ingestion layer from processing workers, and idempotency keys in Redis prevent duplicate charges. Every component is chosen for reliability and scalability, ensuring the system can handle real-world demands. The design includes a retry service with exponential backoff and jitter, ensuring failed transactions are handled gracefully. A PostgreSQL database provides durable transaction state, complete with write-ahead logging for crash recovery. A notification service is ready to alert merchants about payment status changes via webhooks. Every detail is meticulously planned for resilience. By the 25-minute mark, you've added advanced features: circuit breakers to prevent hammering failing banking APIs, a poison pill detector to route problematic transactions for manual review, and rate limiting per merchant to ensure fairness. You discuss every trade-off, from choosing SQS over Kafka to partitioning the database for performance. With 35 minutes on the clock, you put the marker down. The diagram is clean, thorough, and defensible. The senior engineer, mostly quiet until now, studies your work. You feel a sense of accomplishment. Every component is justified, every risk mitigated. But the real test is about to begin. The engineer looks up and asks, "What happens to the person whose rent payment just failed for the third time?" Suddenly, the focus shifts from infrastructure to the human experience. It's not a hard technical question, but it's one you hadn't considered. In all your technical planning, you forgot the most important stakeholder, the user. You realize you haven't designed for the person on the other side of the API call. Does the user get notified? Do they receive multiple emails or none at all? Will they wake up to a late fee, unaware their payment failed? The infrastructure is robust, but the user experience is missing. This is a turning point in the interview and your understanding of system design. The interviewer wasn't just testing your ability to build infrastructure. At Stripe, every senior engineer can do that. The real test was whether you instinctively consider the failure experience from the customer's perspective. In payments, the failure path is more important than the happy path. Trust is built or destroyed when things go wrong. If you had started with the user in mind, the architecture would look different. The notification system would come first, ensuring users know exactly what's happening with their payments. A customer-facing status page would provide real-time updates, and a manual retry trigger would empower users to take action. The technical components remain, but the intent shifts from protecting the system to protecting the user. The lesson is clear. Companies like Stripe aren't just looking for engineers who can build robust plumbing. They want product thinkers, engineers who start with the user's needs and design systems that build trust, especially when things go wrong. It's not enough to have technical perfection. Empathy is just as critical. Every company views system design through a unique lens. At Stripe, it's about protecting both the money and the trust of merchants and end customers. At Amazon, it's about customer obsession, ensuring every failure is addressed from the customer's perspective. At Netflix, availability is king, and at Google, scale and correctness are paramount. Understanding this lens is the key to acing any system design interview. At Stripe, the focus is always on the merchant and the end customer. Every system must safeguard both the money and the trust involved. The interview process is designed to see if you naturally start with the failure mode, the user's experience when things don't go as planned. This perspective shapes every technical decision. Amazon system design interviews are guided by their leadership principles, with customer obsession at the forefront. If your design doesn't address what happens when the customer has a bad experience, you're missing the point. Every decision is filtered through the lens of customer impact. At Netflix, availability is everything. The system must never go down, even if it means serving slightly outdated data instead of showing an error page. Your design must explicitly reflect this trade-off, prioritizing uptime above all else. It's a different lens, but just as critical to understand. Google's lens is all about scale and correctness. They want to see designs that can handle billions of requests with mathematical precision. Every component must be robust and accurate, ensuring the system performs flawlessly at massive scale. Understanding this focus is essential for success. Before any system design interview, ask yourself, what does this company optimize for above all else? Build your system through that lens first, and only then layer in the standard infrastructure. This approach ensures your design aligns with the company's values and priorities. Empathy is a critical skill for engineers. By considering the user's experience, especially when things go wrong, you design systems that build trust and loyalty. Technical skills are important, but empathy sets you apart in interviews and in your career. This interview became a turning point. Every system design interview since then starts with a simple question. Can we talk about what the user sees when something goes wrong? This mindset shift has changed more outcomes than any technical preparation ever could. Technical excellence is still essential. Your architecture must be robust, scalable, and reliable. But it's only half the equation. The other half is ensuring that your system serves the people who rely on it, especially when things don't go as planned. In payments, trust is everything. Users need to know their money is safe and that the system will communicate clearly if something goes wrong. Protecting trust means designing for transparency, reliability, and user empowerment at every step. The failure path is where your system is truly tested. It's easy to design for the happy path, but real value is created when you anticipate and handle failures gracefully. This is where user trust is either built or lost, and where great engineers set themselves apart. A well-designed notification system ensures users are always informed. Whether it's a payment failure or a retry in progress, clear communication prevents confusion and frustration. This is a core component of any user-centric payment system. Empowering users to manually retry failed payments gives them control and reduces anxiety. Instead of waiting helplessly, users can take action, increasing their trust in the system and reducing support requests. A customer-facing status page provides real-time visibility into payment retries and failures. Users appreciate transparency, and it helps them understand what's happening without needing to contact support. This small feature can make a big difference in user satisfaction. Edge cases like repeated payment failures require special attention. Systems should avoid spamming users with notifications or leaving them in the dark. Thoughtful handling of these scenarios is a mark of a mature, user-focused design. Circuit breakers protect your system from cascading failures. By stopping repeated requests to failing downstream services, you preserve system stability and prevent unnecessary retries. This is a key pattern in resilient system design. A poison pill detector identifies transactions that repeatedly fail and routes them for manual review. This prevents endless retry loops and ensures problematic cases get the attention they need, improving overall system reliability. Rate limiting ensures that no single merchant can consume all retry bandwidth, protecting system resources and ensuring fairness. This is especially important in large-scale systems where resource contention can impact overall performance. Every technology choice matters. For example, SQS was chosen over Kafka for its simpler delivery semantics and built-in dead letter support. These decisions are based on the specific needs of the system, not just technical preferences. Partitioning the transaction table by date range in PostgreSQL improves query performance and scalability. These optimizations ensure the system remains fast and responsive, even as data grows over time. Idempotency keys stored in Redis prevent duplicate charges, a critical safeguard in payment systems. Charging a user twice is a career-ending bug, so this layer of protection is non-negotiable. Retrying failed transactions with exponential backoff and jitter prevents overwhelming downstream systems and increases the chances of eventual success. This pattern is essential for building robust, scalable retry logic. Write-ahead logging in PostgreSQL ensures that transaction state is durable and recoverable after crashes. This is a foundational technique for maintaining data integrity in payment systems. Explaining trade-offs is a key part of system design interviews. Whether it's choosing between SQS and Kafka or deciding on a database partitioning strategy, articulating your reasoning shows depth and maturity as an engineer. A user-centric mindset is what separates good engineers from great ones. Always start by considering the user's journey, especially during failures. This approach leads to systems that are not only technically sound, but also deeply trusted by those who use them. Every interview, successful or not, is a learning opportunity. The Stripe interview taught the importance of starting with the user's experience. This lesson has shaped every system design since, leading to better outcomes and more meaningful work. System design is an evolving discipline. Each experience, each interview adds to your toolkit. By reflecting on what worked and what didn't, you become a stronger, more empathetic engineer, ready for any challenge. Before your next system design interview, research the company's values and priorities. Practice designing systems through their lens, and be ready to discuss both technical and user-focused aspects. This preparation sets you apart from other candidates. Platforms like PrackHub offer real-world system design questions organized by company and role type. Practicing with these questions helps you internalize the unique lens each company uses, making your preparation more targeted and effective. The journey from candidate to successful engineer is about more than technical skills. It's about understanding the business, the users, and the unique challenges of each company. This holistic approach leads to better systems and more rewarding careers. Looking back, every system design interview is a chance to grow. By starting with the user's experience and aligning with the company's lens, you not only ace the interview but also build systems that matter. This mindset is the true key to success in tech. To nail your next system design interview, research the company, practice with real questions, and always start with the user's experience. These actionable steps will help you stand out and design systems that truly make a difference. In the end, the best engineers combine technical excellence with deep empathy for users. This blend creates systems that are not only robust, but also trusted and loved by those who depend on them. That's the real secret to success in system design.